So here we're going to talk a little bit about pollution transport basics. We're just going to cover some of the really straightforward stuff here and then do some examples and talk about some of the more complicated processes in class. And this is a picture of the Yosemite fire in 2013. As you can see, spreading quite nicely, if you want to use the word nicely, maybe not, through the atmosphere. Okay, so you already know quite a bit about transport without even really having to think about it. You've seen it happening all around you your entire life. So in this case, this is the Southern California wildfires in 2007. You have a pretty good idea of what's moving the smoke and why it's moving in the direction that it's moving, I imagine. The wind. And the same thing here in this stream. You can tell the stream direction is this way, and the dye that was put into this river is spreading downward with the current. So these are things you know already. This is another thing you know. If you dump paint into a stream, where will it go? You can pause to think about that, but I think you probably already have a good idea that it's going to go downstream. Okay, so what will happen to this blob of paint as it moves downstream? You know this too, but maybe it seems a little less obvious to you. So you have two choices here. Do you think this will happen? You've got this blob of paint and it's all going to move straight downstream and it's keeping its uniform blob shape. So, or is this roughly what's going to happen? As it moves downstream, it will spread out and kind of diffuse through the system or through the stream. And you've seen this happen, you just saw it in the previous slide, so you're probably guessing this is what happens. So you've seen these processes happening. And these two things that are happening are first advection, and that's movement with flow, whether it's wind or current, direction of water flow or direction of wind flow, and spread. So that's movement perpendicular to flow. But sometimes we need to know things more exactly, right? You know these things are going to happen, but you don't know exactly what's going to happen. And why might you need to know that? So let's say you're on the stream and you're a city manager, and here's this city beach and somebody dumped some chemical into the water that you'd rather not have toddlers who go to this beach all the time exposed to. Or perhaps you don't want to deal with their parents after this happens. So we need models to predict for us, is it going to hit this beach? If it does, when? So where will the impacts be? When will they be? And how much? How much of the chemical is going to be there? Is it going to degrade before it gets there? Or is it going to be so diluted that it won't have any impact? So this is why we need math, and this is why we need our models. Okay, so the models describing the physical transport of pollutants, that is models being essentially math and equations, in each medium, which is air and water, whether it's water on the surface or water in soil as groundwater or air, the models and math are essentially identical. So whether you're moving in surface water, groundwater, or in air, you've got these same two processes going on. You've got advection, and then you've got spread. Okay, so back to the two main components, advection, bulk movement with flow, and spread, mixing processes. And next we're going to talk about advection, but I'm going to stop this video here so you can have a little break and then start the next one up about advection.